Heading: Contiguous memory allocation. First point. Contiguous memory allocation is a memory management technique in which each process is allocated a single continuous block of memory. Second point. The operating system allocates memory so that all parts of a process are stored in adjacent memory locations. Side heading: multiprogramming with fixed partitions. First point. In fixed partitioning, main memory is divided into a fixed number of partitions before execution begins. Second point. Each partition can hold only one process at a time. Third point. The number of processes in memory is limited by the number of partitions. Fourth point. Partitions may be of equal size or unequal size. Side heading: first fit. First point. First fit allocates the first available memory block that is large enough for the process. Second point. The search starts from the beginning of memory and stops when a suitable block is found. Third point. It is simple and fast because fewer memory blocks are examined. Side heading: best fit. First point. Best fit allocates the smallest available memory block that is large enough for the process. Second point. The entire list of free blocks is searched to find the most suitable block. Third point. It attempts to reduce wasted memory space. Side heading: worst fit. First point. Worst fit allocates the largest available memory block to the process. Second point. The remaining free space is usually large enough for future allocations. Third point. It attempts to avoid creating very small free blocks. Side heading: multiprogramming with dynamic partitions. First point. In dynamic partitioning, partitions are created at runtime according to the size of the process. Second point. Memory is allocated exactly as needed by each process. Third point. The number and size of partitions change dynamically. Fourth point. This method provides better memory utilization than fixed partitioning. Side heading: advantages. First point. Memory is allocated according to process requirements. Second point. Better utilization of available memory. Third point. Supports processes of different sizes efficiently. Fourth point. Reduces internal fragmentation. Side heading: disadvantages. First point. Causes external fragmentation. Second point. Memory management becomes more complex. Third point. Compaction may be required periodically. Side heading: fragmentation. First point. Fragmentation is the wastage of memory caused by inefficient memory allocation. Side heading: external fragmentation. First point. External fragmentation occurs when free memory is available but scattered into small, non-contiguous blocks. Second point. A process may not be allocated memory, even if sufficient total free space exists. Third point. It is common in dynamic partition allocation. Side heading: internal fragmentation. First point. Internal fragmentation occurs when allocated memory is larger than the memory actually required by a process. Second point. The unused space inside the allocated partition is wasted. Third point. It is common in fixed partition allocation. Side heading: compaction. First point. Compaction is the process of combining scattered free memory spaces into one large contiguous block. Second point. The operating system relocates processes to eliminate external fragmentation. Third point. After compaction, larger memory allocations become possible. Side heading: advantages. First point. Eliminates external fragmentation. Second point. Creates larger contiguous free memory blocks. Third point. Improves memory utilization. Fourth point. Increases the possibility of allocating large processes. Side heading: disadvantages. First point. Compaction is time-consuming. Second point. It requires relocation of processes during execution. Third point. Additional CPU overhead is involved. Fourth point. System performance may temporarily decrease during compaction.